So once we talk about climate change, then we talk about the changes in the climate pattern, like the temperature and precipitation and all these things. But in order to know about the change in climate in any of these variables, we also need to know what was the climate in previous times. Then only we can see how much is the change, right? But beyond 50 years from now, we didn't have any of these modern day observations. Now we have observations of temperature, precipitation, wind, everything, but in earlier times we didn't have. So how do we know what was the climate in previous times? So this is a branch of science, climate science, that is known as paleoclimate. Paleo stands for something which is much older, right? So, but I have already told you there was no observation. So how to get that? So there are some natural proxies which actually store the climate information. So one of these examples is the trees. So trees basically store the information, and this from trees we can extract the climate information from last several to last 1,000 years. I will be explaining to you how. Okay. Now also there is something called the cave deposits. If you have visited any cave, you might have seen the deposits from the ceiling of the cave or from the surface, from the roof, or from the bottom of the cave. Stalactites, stalactites. You go to any cave, actually you will see. So basically these are called the cave deposits. So this looks something like this, which hang from the ceiling, or they grow from the surface. So basically these are stalactites and stalagmites. These are actually limestone rocks. So they have taken this particular limestone rock from a cave in Kadapa district in Andhra Pradesh, and this is the cross section of that, right? So these guys, I mean these speleothems, you also call them speleothem, they contain the climate information almost to last 1 million years. Now I'll be telling you how do we get the information. Okay, so the trees actually grow something which is known as the tree ring, annual ring actually. Every year they grow the ring. If you meticulously count the number of these rings, you will get to know what is the age of this particular tree. But we can deduce something more than that. So basically these rings were formed in a particular year, and in that particular year, and now I should tell you about something, one more thing that you will need to understand this. So you guys are from science background?
Yes.
Civil engineers. So you know isotopes and all, right?
Yes.
So carbon's atomic number is 12.
And atomic mass is different.
Exactly.
Of and protons are different.
Electron remains proton and electron same thing. Yeah, your friend told the right thing. So carbon's most dominant ones, the stable one is carbon 12. It also has got two more isotopes, carbon 13 and carbon 14. Now carbon 14 is used for radioactive dating. Computing the half-life, you can know the date of age of any sample. All the old civilizations like Indus, Harappa are found using the radiocarbon dating. Now carbon 13 is not radioactive, but its ratio of carbon 13 to carbon 12 in ambient atmosphere is fixed. In any reservoir, like the plant it is fixed, like in the fossil fuel it is fixed, like the ocean it is fixed. So if you can measure these things, what is the ratio of carbon 13 and carbon 12, you can find out multiple information. Now if you take this tree ring, and if you take out the cellulose sample, because tree is what? Wood is what? Cellulose. Right? So if you take the cellulose sample, you have the micro drills to take out the cellulose, and in that cellulose sample, similar to carbon, oxygen also has got isotope. Oxygen 18 is there, and hydrogen also has got hydrogen 2, that is deuterium. So you can actually find out what was the carbon 13 and 12 ratio in that particular ring. What was the oxygen 18 to oxygen 16 ratio, right? So you can compute this for all these multiple years. Let's say, assume that this is a record of 200 years. Okay, let's say. Now, once you create this record, you will be seeing a time series in a particular year. What was the 13 to 12 ratio, oxygen 18 to 16 ratio, and this tree is from a region in Uttarakhand, from Nainital, right? So now Nainital, for last 50 years, I have the observations, I have the climate observations, temperature, precipitation. So I can now correlate the 50 years of this record to 50 years of temperature and precipitation, and that is how I calibrate my scale. Once my scale is calibrated, because what happens, the growth of any tree, that depends on the stressors. If there is a water stress, if there is a deficient rainfall year, drought year, the tree ring growth will be affected. If it is excessively hot, then you might have seen that in the hot year your crop yield is less because plant growth is not proper. So those conditions can be identified from my 50-year record. That is my calibration. Once I calibrated my scale, then I can use the rest 950 years to reduce the information. Initially I calibrate my scale, and then I use the scale to go longer in back. So like that we can actually find out. So this is one such tree ring climatology, what I explained to you, and from that you see we are deducing the information from 1450 current year, 1450, so now it is 2020, something like that. So all this information you can see. In some year there was some abnormal cooling, okay, In some year there was some warming, excessive heat. See the information we can find out. Also we can find out if there were some, precipitation anomaly. This is the precipitation anomaly, right? So you can find out all this information from here, right? Now the speleothem samples also work in the same way. So how is it formed? So basically in atmosphere, in air actually you have carbon dioxide. So when it rains, so if you add carbon dioxide in water, that becomes carbonic acid, which is a mildic acid. And in your surface you have limestone. So what happens if you put acid to limestone? They react, they form calcium carbonate. So that's ये जो चूना जो होता है ना calcium carbonate, so that gets dissolved in water, and on the earth surface you have some cracks, some minor cracks and holes. So that dissolved lime water that goes through that crack, seeps through that crack, and in the process the water gets evaporated. So then only the solid part, the limestone remains, and that seeps from the top of the roof, from that hole in the roof, and it grows towards, the gravity is pulling it downward, right? So it grows, and this growth process is very slow. You are seeing this, but this guy was growing for 1 million years almost, right? So you will see this entire thing like here. The same thing, the picture is kept here. You are seeing it is growing. So this part is much more younger, recent times, and this is the much older time, right? Now we, like, similarly we have taken cellulose sample from here. We take the calcium carbonate dust from here. We have micro drills. We can take from individual links. We can take, and we can analyze for the similar things. We can find out temperature anomaly and other things from this record. So this branch of study, this is known as dendroclimate. Dendro is related to treeing. Dendroclimate, because we are deducing the climate information from the treeing. There is a dendroclimate, right? So, and there are many such proxies. You guys heard about corals, because in Indian island also we have the coral reefs that Ram Setu people say. In Andaman, that is coral islands. If you go to Andaman, some Maldives, our Lakshadweeps, these are all. In Australia, we have Great Barrier Reef, right? Nowadays, due to warming of your sea and then some acidification, these corals are getting bleached. Basically, they are dying out, right? But these corals actually grow for a very long time. Imagine, see, you yourself said Lakshadweep and Maldives, right? These are now islands. So imagine how many corals were deposited and then this island was formed. So how long the procedure is. If you can get that core and date it, then you can also find out. So corals are there, foraminiferae, they are we call forams. Then there are the speleothems, free rings. So people can study all these things to deduce about the past climate. Right?
How you decide how you decide to collect this sample? Like there is some random rocks are there. How you decide?
Yeah, very good question. So before that, let me tell you. So this is, I told you this is from a cave in Kadapa, right? The Kadapa cave that is in Andhra. And this tree ring that was taken somewhere here in Nainital, okay? So basically, in our experience, we have seen, see, all the trees they grow the tree rings, but in not all the trees you will see such prominent patterns. Like in this tree, this is the same thing. Only thing I've taken a section, not the entire thing. You see, the rings are very prominent, right? In some cases, distinct. But you guys heard about Sundarban mangrove trees? If you go mangrove forest, if you go to Sundarban and take a section, you will not see such nice patterns. That the rings will not be such uniform. They might be mixed with each other. So basically, all the trees grow tree ring, but some of the trees like teak is the best. So their tree rings are most prominent. So this we know from our experience. So we preferably look for the trees like teak, some other plants which are similar to teak. Those actually give you the base rings. That is how we decide on the plants. And also, see, from the age. So there are different ages in geology. There are different ages: Cenozoic, Mesozoic, different ages. So we know that which part in India or which part in the globe, the structures, the rocks are much older. So usually go for there, which are much older, which can give you longer record, and we take. But but initially you have no idea to know. Once you collect more and see this, then only you get to know that okay, I am getting good record from this cave, and another cave I am not getting good record.
Like, this is just a random process first.
Yeah, initially it's yes, yes. Because I told you mangroves don't have ring. So someone might have studied, then only we know they don't have ring. Otherwise, how do I know? Yeah.
Sir, as you say, you scale, you collect data from here and there,
Yes.
and then you scale it. So in between that, if there any circumstances came out that the sudden changes, just like here,
Yeah.
You took a data from here and you take a data from here.
Right.
Okay.
Right.
Then this peak, how you calibrate that sudden change means if there is a disaster change in the circumstances or climate, then how can you scale it?
Yeah, I'll answer to that. So let's say this is the entire record I'm getting for a tree, from a tree, okay? Now let's say 1950, my surface observation started. So 50 to 2000, this period, I can have another evidence for that
You have
event,
another form of
another
data.
formula. So there I calibrate that. That is called the calibration of the scale. जैसे कि okay, let's say I give you a scale, 1 meter scale, right?
Okay.
Now this length you don't know, but I give you a scale that is the standard. Now I tell you that you mark 1 meter on this. So what you will do, you will take your scale and mark 1 meter on this.
Yeah.
So next time, even if I don't have your scale, I know okay, this distance is 1 meter. So this is called calibration. I am doing the calibration for the period I have the other meteorological record observations available with me. Done. Once I know, then the remaining part
Means
I can
you mean to say you are doing actually cross check from the
cross check.
other
Exactly,
data.
exactly. Like I told you, once I mark 1 meter on this, then I don't need the scale. I know 1 meter is already marked, and
And
this
what
thing.
I'm asking, suppose I have a 1 meter chain.
Yes,
Okay, if I cut the 2 or 3 pins in between that,
yes.
but you still measure that 1 meter.
Oh, you mean the error? How
Yeah,
much
yeah,
is the
yeah,
error?
yeah,
Yeah, there are errors. These are not error free. But then the thing is, how much error do you have? We are talking about, let's say, 1,000 years. So I'll give you an example. Let's say in 1900 there was a drought. I might come up with a year of 1901 or 18,099. 1 year, 2 year, I
Yes.
might be uncertain. But it is not that the drought was
Cannot
in
miss the
1900.
drought.
Yes, yes.
You cannot miss
I
the
mean,
drought.
the error bars are very minute actually. We have many other cross correlation techniques to verify this actually. So the errors are there, but not more than 1 or 2 years. Whereas we are talking about a scale of 1,000 years.
1,000 years.
Usme 1 year, 2 year, it doesn't matter, right?
This is very high technique, I think.
Yes.
Recently developed.
This has been developed in last 70, 80 years, I would say, but still people are working on this.
Okay.
Yeah. I'll show you something more interesting. See, this is the entire cross section of the trunk of a tree. But usually we don't do this. If a tree is alive, we don't go and cut it because if you cut it, will die, right? This is only allowed when there is a log. The tree has died, the log is there. With the permission of forest department, we collect this. Okay. Usually we don't do. What we do, this is the instrument using which we collect the samples. So, this is called something called the coder. You see there is a drill bit here, the sharp edge is there, and you see it's like a screw. So you give it a circular motion, it will be translated into a
Yes.
linear motion, like your screw.
Kind of drill.
Kind of drill, it's a drill. What we do, we fix it here. I don't have a screwdriver here, but you can open it. This comes out, you can lock it. So it becomes like a lock. Okay. Now you point this to any tree and then you rotate it. So it will go inside. You are drilling the tree. Once the drilling is done, this is a spoon, this is a spatula. You put this inside like this, and then once you take it out, something like this come out.
Okay.
This is a core of the tree trunk diametrically.
It doesn't harm that way.
It doesn't harm that. You are very right. So there will be a minor cut, but we feel that using wax, it doesn't affect the tree. So using this, so globally there is this database called tree ring database. In India, we have mostly found that the trees in the Himalayan region, the temperate region like Nainital, Almora, Uttarakhand, Himalaya, the tree rings actually have very good chronology. Okay, yeah, conifers mostly. So we create the chronology, and this all data. So there is something called National Oceanic Administration, National Ocean and Atmosphere Administration. Like NASA, there is another agency called NOAA by USA, and they have this database. So not only from India, from everywhere in the world, people have put this feeding database. If you want to use it for some purpose, you can download. So my institute has collected this feeding from this region. You can see Uttarakhand, Kashmir, Himachal, this region. Then some places in Kerala that rainforest basically. There also you can see the teak woods and all in Bhopal, like in MP also Betul, Kanha, this region. But these are semi-arid regions. Okay, there also you can get in Sikkim you can get. So there are databases, and the more we can find out, the better for our research actually. Then get information at multiple places.
Thank you, sir. It was very nice talking to you. It was very knowledgeable.
Thank you. Would you mind give us your feedback?